Yeah, so this is just my temporary solution to record this for a student of mine. So let's say that we wanted to um, a piecewise function. What I would recommend is, first of all, you look at these ranges, right? And this is describing along the x-axis, left to right, where we're going to end up graphing. So I typically draw in right away -1, that would be right here. And then from -1 to 2, that would be this area here. So I'm drawing in boundaries just to remind myself, okay, so this function will be in this area, this function will be in the middle there, and then this other function here will go on the right. And then from there, we just want to draw those, keeping in mind we have to be careful about the boundaries, where we're actually equal to the boundary, where we are not. So 3x squared, that's just going to be a parabola. If you want, you can plug in some actual points, like you could plug in, say, -3 if x is -3. Well, -3 squared is quite large, right? It's 9. 9 times 3 is 27, so that's going to be like way up here. So that ends up being not super helpful. If we move to -2, though, plug in -2. -2 squared is 4. 4 times 3 is 12, so that would be somewhere over here, I guess. And so basically, we just end up with this kind of massive parabola approaching, I really hate those 2 points, approaching what happens at -1. -1 squared is 1. 1 times 3 is 3. So we end up with an open circle at 3. But otherwise, yeah, it's just going to go, super high up, super steep parabola there. And then we switch. I used an open circle there because, of course, we have less than. And then we switch. And so now we're going to have a solid dot at the new location, which is -1, because that's what the function says to do. It says let your y value be -1. This is a constant function, so we simply move all the way across. And then again, we're going to put an open circle because we don't have the little bar. We're not equal to 2 there. We're less than 2. And then we would switch over again for greater than or equal to 2. So that's this orange area over on the right side of our graph. We just want the linear function x plus 3. Once again, you could plug in some points if you want 2. For example, if x equals 2, we want to be at 5. So 2 comma 5. Solid dot, because we, again, have the bar. And then it's just going to go up 1 over 1, up 1 over 1, etc. And so that's going to continue on and on forever, looking like that. Let's do the same thing on number 10 here. So I will again start with my boundaries. X is less than 0, so that's going to be everywhere to the left of the y-axis. And then we have another range between 0 and 3. That will be there. And then everything to the right. So this function, once again, will be all the way on the left. And then we've got this middle function, 2x minus 1 for the middle. And then finally, we've got the constant function 5. That'll be over here on the right. X less than 0, so definitely using some open circles. We want an open circle at 0, because when you plug in here 0 squared plus 2 times 0, of course you get back 0. And once again from there we could plug in some other values. If we do -1, we should get back, well, let's see, -1 squared is 1. Plus 2 times -1, that's 1 minus 2, that's -1, so that would go there. If we plug in, I think -2 is maybe going to be the same thing. Maybe not. Where's the vertex on that one? Maybe that was the vertex. So if we plug in -2 squared, we get 4 plus 2 times -2. That ends up being 4 minus 4 is 0. Yeah, that was the vertex. And so then from there, it's going to go up and over, and so we get that kind of parabola. We switch over to the linear function, 2x minus 1. So again, -1 means it's going to go down. We actually want the solid dot there because, again, now we're looking at the bar. And then up 2 over 1, up 2 over 1, until we get to an open circle. Because our range here stops at 3. It's not inclusive of 3. And now we finally switch over and we get the constant function 5. And it happens to be the case that because that last one also ended at 5, now we actually do get to fill in the dot because of the bar on that final range of values. X is greater than or equal to 3. You'll notice neither of these are continuous. We have to pick up the pen or pencil as we draw these. Number 10 got close. If that parabola part was moved down 1 unit, it actually would have ended up being continuous, but it was not. So that's that. That's how you graph piecewise functions.